Hello everyone, this is Ramachandran, Math Tutor from Online Math for All. In this video, we are going to see 10 hard SAT math problems with step-by-step solution for each problem. This is just part 1. Like this one, we are going to launch many parts. Keep watching our YouTube channel and have a good score in SAT. Now let's go to the problems. Point F lies on a unit circle in the xy plane and has coordinates 1, 0. Point G is the center of the unit circle and has coordinates 0, 0. Point H also lies on the circle and has coordinates -1, y, where y is a constant. Which of the following could be the positive measure of angle FGH in radians? Okay, first let me draw a unit circle in the xy plane. Here I have drawn a circle. Okay, let me mark this is x-axis, this is y-axis. And the question says G is the center of the circle and has coordinates 0, 0. 0, 0 means its origin, that is a point of intersection of the x-axis and y-axis. So this is the center of the circle given by the point Z, 0, 0. Since this is unit circle, it has radius 1 unit. The line segment we have over here, the line segment we have over here, and this line segment, this line segment. The 4 line segment I have mentioned represent the radius. So the length of this line segment is 1, and here we have 1, here we have 1, here we have 1. Because the radius of the unit circle is just 1 unit. Then we'll have the value 1 on the x-axis over here, and here we'll have a -1 because this is the negative side of the x-axis. And the point over here is 1, 0 because this is the x-intercept. And the point over here is -1, 0. And we know that the point F represents a -1, 0. So actually this is a point F. And now we have to identify the location of this point -1, y. Okay, now let's find the point where we get the x-coordinate is -1. So here we get this point where the x-coordinate is -1. And we may think, we may have this point somewhere else over here in the second quadrant or third quadrant, because in both the second quadrant or third quadrant, the x-coordinate will be negative. But when I consider the point, this point over here in the second quadrant or third quadrant, the value of x-coordinate will not be -1. It will be somewhere between -1 and 0. So this is the only point we get the x-coordinate -1. So the location of this point -1, y is -1, 0. So this is a point H. Okay, here we have the point F. Here we have the center of the circle, that is point G. And here we have the point H. Okay, now what we have to do is we have to get the measure of angle FGH. Clearly, this is a straight angle. We know that the measure of a straight angle is 180 degrees, or it's a pi radians. Okay, clearly the angle measure FGH is a pi radians. In case when I complete one full rotation, I'll be getting 2 pi over here. Again, when I reach this position, I'll be getting 3 pi. Or when I complete again one full rotation, 3 pi positive 2 pi will be 5 pi. So here at this position H, I am getting odd multiple of pi. That is pi, 3 pi, 5 pi. It will keep going. Now, to get the measure of angle FGH in radians, we have to consider the odd multiple of pi in the given answer choices. That is 25 pi. 25 pi is a odd multiple of pi. Therefore, the measure of angle FGH in radians is 25 pi in answer choice D. The correct answer choice for this question is D. The function g is defined by g of x equals to absolute value of x over a, -14, where a is less than 0. What is the product of g of 15a and g of 7a? Okay, here we have the function g of x, and it contains a constant a, and a is less than 0. Since a is less than 0, we can consider any negative value for a. Okay, now let me assume that the value of a is -1. Okay, when a is equal to -1, what is the value of this 15a and this 7a? Okay, now let's evaluate this one. That is 15a equals to 15 times -1, that is equal to -15. And 7a equals to 7 times -1, that is equal to -7. And also let me take the function g of x, that is g of x equals to absolute value of x divided by, and for a we can plug in -1, and here we have -14. Then we get g of x equals to absolute value of x divided by -1 is a negative absolute value of x and -14. Okay, our aim is to get the product of g of 15a and g of 7a. Okay, now let's get the product. That is g of 15a times g of 7a equals to g of, we know that 15a equals to -15. So we can plug in this -15 for this 15a. Okay, let me plug in times g of, for 7a, we have -7. Let me plug in a -7 for 7a. Okay, now to get the value of this g of negative 15, I have to plug in this negative 15 for x over here. Then I'm getting negative of absolute value of negative 15, negative 14. So this is the stuff I'm getting for g of negative 15 times to get g of negative 7, I have to plug in this negative 7 for x over here. Then I'm getting a negative of absolute value of negative 7 and negative 14. Okay, here negative absolute value of negative 15 is just 15, negative 14 times absolute value of negative 7 is 7, negative 14. Okay, here when I combine negative 15 and negative 14, I am getting negative 29 times when I combine negative 7 and negative 14, I am getting negative 21. Here, negative times negative will be positive. When I multiply this 29 and 21, I am getting 609. Okay, here I got the product of g of 15a and g of 7a, that is 609. Here we have a question. We have taken a equals negative 1 because the question says a is less than 0. When a is less than 0, we may consider multiple values for a, not just negative 1. We can consider a equals to negative 2, a equals to negative 3, a equals to negative 4. So all the values we consider for a will be negative because a is less than 0. What if I consider a equals to negative 2 instead of negative 1? Will I be getting the same value 609 as the product for g of 15a and g of 7a? Yes, it will be. Even if I consider negative 3 as a value for a, I'll be getting the same value 609 as a product for g of 15a and g of 7a. How can I be so certain? For that, we can consider the function g of x we have over here. In the given function g of x, we have absolute value of x in numerator, a in denominator. When I consider this one g of 15a, that is I want to get the stuff that is equal to g of 15a. For that, I have to plug in this 15a for x over here and also here. When I plug in 15a for x over here in numerator, I'll be getting a in numerator and a in denominator. So the a in numerator and the a in denominator will cancel out. And the same result will be getting for g of 7a. That is when I plug in 7a for x over here, I'll be having a in numerator and a in denominator, then the a will cancel out. So it doesn't matter what value we have for a, so that a less than 0. So we'll be getting the same result as a product for g of 15a and g of 7a, that is 609. An equilateral triangle is inscribed in a circle with a radius of 8 inches. What is the area of the region that lies within the circle but outside the triangle in square inches? Round your answer to the nearest tenth. Okay, first let me draw a circle with an equilateral triangle inscribed in it. Here I have drawn a circle where an equilateral triangle is inscribed. According to the question, we have to find the area of the region that lies within the circle but outside the triangle. Okay, now let me share the region for which we have to find the area. So this part, and this part. The region I have shaded in red color, I have to find the area. So to get the area of this region, what I have to do is I have to find the area of the circle. From the area of the circle, I have to subtract the area of this triangle. We can find the area of the circle using the radius given over here. We know the formula to get area of a circle, that is pi r square. We can plug in this 8 for r over here and we can get the area of the circle. Now we have to find the area of the equilateral triangle. Let me say that the length of each side of this equilateral triangle is a. Here we have a, here we have a. All the three sides are equal because it's an equilateral triangle. And we have the formula to get area of an equilateral triangle, that is square root of 3 over 4 times a square. Once we get the length of one of the sides of this equilateral triangle, then we can plug in that value for a over here and we can get the area of this equilateral triangle. Okay, now our aim is to get the length of one of the sides of this equilateral triangle. Okay, now what I'm going to do is I'm going to draw two radius to this circle. Okay, let me draw it. Here one radius and here one radius. And also let me mark O as the center of the circle and say this is point A and this is point B and this is point C. Since ABC is an equilateral triangle, at each vertex we'll have a 60-degree interior angle measure. Okay, here an equilateral triangle ABC is inscribed in a circle and we have all the three vertices A, B and C on the circle. When we draw a radius to each vertex, the radius will bisect the interior angle. Okay, here we have drawn a radius OA to the vertex A of this triangle. Then this radius OA will bisect this interior angle 60 degrees. That is, it will divide this 60-degree angle measure into two equal parts. So that is 30-degree angle measure over here and here we have 30-degree angle measure. Now let's consider the triangle OAB over here. It is an isosceles triangle because the length of OA and the length of OB are equal because both of them are radius. That is, the length of OA is 8 and the length of OB is also 8. The radius of the circle is given in the question itself. Okay, so here we have an isosceles triangle OAB over here. Now let me draw an altitude to this triangle from the vertex O to the side AB. Okay, here I have drawn altitude. Since this line segment is an altitude, it will intersect the side AB at right angle. Okay, in this isosceles triangle, I have drawn an altitude between the two sides of equal length. In an isosceles triangle, if I draw an altitude between the sides of equal length, then altitude will bisect the third side of the triangle. That is, this altitude will divide this side AB into two equal parts. Okay, now let me say this is point D. Now the length of this line segment AD, the length of this line segment DB are equal. Okay, now let's consider the right triangle OAD over here. Here we have right angle, that is 90 degrees. Here we have the interior angle measure 30 degrees. Then the measure of this interior angle has to be 60 degrees. So that the three interior angles will add up to 180 degrees. Now it is a 30, 60, 90 special right triangle. Okay, in this triangle, let's consider the side which is opposite to the smallest angle 30 degrees. So that is side OD. Then this is the shortest leg of this triangle because it is opposite to the smallest angle 30 degrees. In 30, 60, 90 special right triangle, usually we assume x as the length of the shortest leg. Now, to get the length of the next longer leg, the leg which is opposite to 60 degree, what we have to do is we have to multiply the length of the shortest leg by square root of 3. That is x times square root of 3. So this is the length of the side AD. Now let's consider the third side of this right triangle, that is OA. So it's an hypotenuse because it is opposite to the right angle. Now to get the length of the hypotenuse OA, we have to multiply the length of the shortest leg by 2. Then 2x represents the length of this hypotenuse OA. But already we have the length of this hypotenuse OA, that is the radius of the circle 8. So this 2x and 8, both of them represent the same stuff. When 2x equals to 8, we get x equals to 4. Okay, here I got the value of x. Now we can replace this x over here by 4. Then this x times square root of 3 will become 4 times square root of 3. Let me write it over here. Already we know that the length of this line segment AD and DB are equal because its altitude will divide this AB into two equal parts. Okay, then the length of this line segment DB is also the same. That is 4 times square root of 3. Then what is the length of this line segment AB? We have to add this 4 square root of 3, 4 square root of 3. Then we get 8 times square root of 3. So now I got the length of one of the sides of this equilateral triangle. That is 8 times square root of 3. Okay, now what we can do is we can find the area of the circle and also area of the equilateral triangle. Okay, first let me get the area of the circle. Let me write this over here. Area of circle equals to, the formula is pi r square. And here we can plug in the radius 8 for r over here. Then I'm getting pi times 8 square. Okay, here the value of 8 square is 64. That is 64 pi. Okay, now let me get the area of the equilateral triangle. So that is equal to, the formula is square root of 3 over 4 times a square. Square root of 3 over 4 times, here a represents the length of one of the sides of the equilateral triangle. Here we got that 8 times square root of 3. We can plug in this 8 times square root of 3 for this a over here. Then I'm getting 8 times square root of 3 whole square root of 3 over 4 times, here two values are multiplied and there is a common exponent. Now what we can do is we can take this exponent 2 separately for each value and multiply the results. That is 8 square times square root of 3 the whole square. Then this square and square root will cancel out. Then I'm getting a square root of 3 over 4 times the value of 8 square is 64, and here we have 3. 4 goes into 4 1 times and 4 goes into 64 16 times. Okay, when I multiply this 3 and 16, I'm getting 48. 48 times square root of 3. Let me write it over here. Okay, here I got the area of the circle and area of the equilateral triangle. Now, to get the area of the region that lies within the circle but outside the triangle, as we have planned already, we have to subtract the area of the equilateral triangle from the area of the circle. Okay, let me do it. 64 pi negative 48 times square root of 3. Now we can use the Desmos graphing calculator to evaluate the value of this expression. When I use the Desmos graphing calculator, I am getting 117.9234 and it keeps going. According to this instruction, we have to round our answer to the nearest tenth. When I round this value to the nearest tenth, I am getting 117.9. Here we have the radius of the circle in inches, then the area we got over here must be in square inches. Therefore, the required area is 117.9 square inches. Here we have a system of two linear equations. In the given system of equations, A and B are positive constants. The system has no solution. If B is P% less than A, what is the value of P? Okay, when I consider the two linear equations in the given system, they are not in general form or slope intercept form or standard form. Whenever I want to solve this kind of problems, the given system of two linear equations must be in one of the three forms, general form or standard form or slope intercept form. Okay, here what I'm going to do is in my first step, I'm going to write both the equations in standard form. That is ax positive by equals to c. That is we have x term and y term on the one side of the equation and the constant on the other side of the equation. Okay, now let me write the first equation in standard form. Let me take the first equation as it is. It is 3a over 8 times x equals to 3 over 2 positive 15 over 8 times y. Okay, first let's get rid of the denominators we have over here. We have denominators 8, 2 and 8. The least common multiple for the three denominators 8, 2 and 8 is 8. Let's multiply both sides of this equation by 8 to get rid of all the denominators. Okay, let me do it. Let me multiply the left side by 8 and now let me multiply the right side by 8. Okay, here this 8 will cancel, then I'm getting 3ax. Here we can distribute this 8 to this 3 over 2. And also this 15 over 8 times y, then I'm getting 8 times 3 over 2, positive 8 times 15 over 8 times y. Here this 8 will cancel out. 2 goes into 2 one times and 2 goes into 8 4 times. Then I'm getting 3ax equals to 4 times 3 is 12, positive 15y. Okay, now let me subtract 15y from both sides of this equation. When I do so, this positive 15y, negative 15y will cancel out. Then I'm getting 3ax and negative 15y equals to 12. When I consider the terms of this equation, everything is a multiple of 3. So what we can do is that we can divide each term of this equation by 3 to simplify further. Okay, now let me do it over here. Let me divide the first term 3ax by 3. Then the second term negative 15y by 3. On the right side 12 by 3. Okay, here this 3 will cancel out. I'm getting ax and negative. When I divide 15 by 3, I'm getting 5. That is 5y. On the right side, when I divide 12 by 3, I'm getting 4. Okay, here I got the first equation in standard form. Okay, now let's get the second equation in standard form. Let me write the second equation as it is. That is 18 over 7 times y negative 4 equals to 4b over 7 times x negative 9. Okay, here we find the constants on both sides of the equation, negative 4 and negative 9. To get the constant on the left side, let me add 4 to both sides of this equation. When I do so, here negative 4, positive 4 will cancel out. I'm getting 18 over 7 times y equals to 4b over 7 times x. When I combine negative 9 and positive 4, I'm getting negative 5. Here we find 7 as denominator on both sides of this equation. To get the denominators on both sides, we can multiply both sides of this equation by 7. Okay, let me do it. Okay, on the left side, this 7 will cancel out. I'm getting 18y equals to, we can distribute this 7 to this one and this one. Then I'm getting 7 times of 4b over 7 times x. 7 times a negative 5 is a negative 35. Here this 7 will cancel out. Okay, let me continue over here. We get 18y equals to 4bx negative 35. Now let me subtract 4bx from both sides of the equation. Let me do it. Then this positive 4bx, negative 4bx will cancel out. I am getting negative 4bx positive 18y on the left side. On the right side, we have negative 35. Okay, here I got the second equation in standard form. Okay, now we got both the given equations in standard form. Okay, now let me erase this stuff and continue the problem. Now, let me consider a system of two linear equations in standard form. That is a1x positive b1y equals to c1. The other equation is a2x positive b2y equals to c2. Now, let me get the ratio of the coefficients of x. Then I'm getting a1 over a2. And the ratio of the coefficients of y, that is b1 over b2. And the ratio of the constant terms c1 over c2. Okay, if this system of two linear equations in standard form has no solution, then the ratio of the coefficients of x and the ratio of the coefficients of y must be equal. And these two ratios will not be equal to the ratio of the constant terms. Always you have to remember this stuff when a system of two linear equations in standard form has no solution. So the same logic we can apply for the given system of two linear equations that we have already got it in standard form. Okay, let me get the ratio of the coefficients of x, that is a over negative 4b, and the ratio of the coefficients of y, that is negative 5 over positive 18, the ratio of the constant terms of 4 over negative 35. According to the discussion we have done over here, the ratio of the coefficients of x, the ratio of the coefficients of y must be equal, and these two ratios will not be equal to the ratio of the constant terms. Since these two quantities are equal, we can consider the equation over here. Now we can use cross multiplication to simplify this equation. That is, we have to multiply the numerator on the left side by the denominator on the right side. A times 18 is 18a. Now we have to multiply the numerator on the right side by the denominator on the left side. Negative 5 times negative 4b is 20b. Now let's solve for b in this equation. We have to divide both sides of this equation by 20. When I do so, this 20 will cancel out. When I divide this 18 by 20, I am getting 0.9. That is 0.9 times a equals to b. Okay, here I got the value of b in terms of a. Now let me consider the other information we have in the question. That is b is p percentage less than a. Now we can write this stuff as an equation. That is b equals to p percent less than. Since p percent less than a, we have to subtract this p from 100. That is 100 negative p percentage times this quantity a. So here I have written this statement as an equation. Now for this b, we can plug in this 0.9a. Let me plug in 0.9 times a equals to 100 negative p percentage times a. Now let me divide both sides of this equation by a. Let me do it. Then this a will cancel out. Here a will cancel out. I'm getting 0.9 equals to 100 negative p percentage. Okay, now on the right side, we can write this percentage as a fraction. Then I'm getting 100 negative p over 100. Okay, let me continue over here. 0.9 equals to, here 100 is a common denominator for 100 and negative p. Now we can take this 100 as denominator for this 100 and negative p separately. Then I'm getting 100 divided by 100 negative p over 100. Okay, 0.9 equals to, when I simplify this one, 100 over 100 is just 1 negative p over 100. Okay, now let me subtract 1 from both sides of this equation. This 1, negative 1 will cancel out. When I simplify this positive 0.9 and negative 1, I am getting negative 0.1 equals to negative p over 100. Okay, now let me multiply both sides of this equation by 100. Okay, here this 100 will cancel out. On the left side, when I multiply this negative 0.1 by 100, I'm getting negative 10. On the right side, we have negative p. Our aim is to get the value of p. So here we have negative p. To get out this negative sign, we can multiply both sides of this equation by negative 1. When I multiply negative 10 by negative 1, I'm getting 10. When I multiply this negative p by negative 1, I'm getting p. Okay, here I got the value of p. Its value is 10. 5x over 3 equals to negative 3y over 2 negative 11 over 6. The equation above gives a graph of a line in the xy plane. The line is then shifted left 4 units and shifted up 5 units. What is the x-coordinate of the x-intercept of the resulting line? Okay, here we have two transformations. One is an horizontal transformation of 4 units to the left and a vertical transformation of 5 units up. After we apply these two transformations on the given line, we'll be getting the equation of the resulting line. For the resulting line, we have to find the x-coordinate of the x-intercept. Okay, before we start working on this problem, let's understand some stuff about horizontal and vertical translations. Okay, now let me write the stuff. Here I have written the stuff. There are two types of horizontal translations. One is to the left and the other one is to the right. When I do horizontal translation to the left by h units, then x in the original equation has to be replaced by x positive h. When I do horizontal translation to the right by h units, the x in the original equation has to be replaced by x negative h. Okay, now in vertical translation also we have two types. One is down and other one is up. When I do vertical translation by k units down, then y in the original equation has to be replaced by y positive k. When I do vertical translation by k units up, then y in the original equation has to be replaced by y negative k. Okay, now let's come to the given information we have over here. An horizontal translation of 4 units to the left, then x in the original equation has to be replaced by x positive 4, and a vertical translation of 5 units up, then y in the original equation has to be replaced by y negative 5. That is, in the given equation, we have to replace this x by x positive 4 and this y by y negative 5. Okay, then we get 5 times x positive 4 divided by 3 equals to negative 3 times y negative 5 divided by 2 negative 11 divided by 6. This is the equation of the resulting line, and for this line we have to get the x-coordinate of the x-intercept. Okay, now we can go to Desmos graphing calculator and give this equation as an input and get the x-coordinate of the x-intercept. Okay, now let's go to Desmos graphing calculator. Here we have the equation of the resulting line. Now let me give this equation as input over here. Okay, let me do it. That is 5 times x positive 4 divided by 3 equals to negative 3 times y negative 5 divided by 2 negative 11 divided by 6. Okay, here I got the line for the resulting equation. And now let's identify the x-intercept of this line. So that is where the line intersects x-axis. It's over here. That is negative 0.6 comma 0. So the x-coordinate over here is negative 0.6. Therefore, the x-coordinate of the x-intercept of the resulting line is negative 0.6. Here we have a table of values. The frequency table above gives a distribution of ice in inches for a random sample of 56 male basketball players and 56 female basketball players. What is the positive difference between the median height in inches for male players and the median height in inches for female players? Okay, to answer this question, we have to get the median height for male players and also median height for female players. Okay, whenever I want to find median for a data, the values in the data have to be arranged in ascending order. That is from least to greatest. Here, this data is about the heights of the students. Already the heights are arranged from least to greatest. Okay, now we have to find the value of the expression n positive 1 divided by 2. Actually, this n represents a number of values in the data. Okay, in the first one, we have 56 male players, and for 56 male players, we have 56 heights. So that is, there are 56 values in the data over here. So we have to plug in that 56 for n over here because n represents a number of values in the data. Okay, then we get 56 positive 1 divided by 2 equals to 57 divided by 2. When I divide 57 by 2, I am getting 28.5. That is, when the values of the data are arranged from least to greatest, the value of the portion of 28.5 is considered to be median. Okay, now let's consider the data we have on the table. Already the values, I mean the heights are arranged from least to greatest. Now let's go to the second column where we get number of male players. Okay, here we have to identify the 28.5th player. Okay, now let me get the total number of players in the first 4 categories. That is 2 positive 5 is 7, 7 positive 10, 17, 17 positive 10, 27. There are 27 players in the first 4 categories. Okay, now let's get the total of the first 5 categories. Already we have the total for the first 4 categories. That is 27. 27 positive 19 is 46. That is, we have the first 27 players in the first 4 categories, and from 28th player to 46th player over here in this 19. That is 28th position to 46th position. We have players over here. Okay, so it's very clear the player whose position is 28.5 is over here. The height corresponding to this one is 76. So that is the median height for male players is 76 inches. Now let me do the same thing for the category of female players. Okay, in the category of female also we have the same number of players, it is 56. Okay, now let me get the total number of players in the first 2 categories, that is 16. Now let me get the total number of players in the first 3 categories, that is 16 positive 12, that is 28. Now let me get the total number of players in the first 4 categories, that is 28 positive 12, it's 40. Okay, here we have the first 16 players in the first 2 categories. Now in this one, we have the players from the position 17 to 28. And here in this category, we have the players from the position 29 to 40. Okay, it's a little tricky because we have to get the height of the player whose position is 28.5. Okay, here up to this we have 28 players, and in this one we have the players from 29 to 40. How can I get the height of the player whose position is 28.5? For that, let's consider the height of the player whose position is 28. We know that the player who is at the position of 28 is over here. So to this one, the corresponding height is 70. So that is the height of the player who is at the position of 28 is 70 inches. Now let's get the height of the player whose position is 29. So the player who is at the position of 29 is over here. So the height corresponding to this one is 73. Now to get the height of the player whose position is 28.5, what we have to do is we have to find the average of the heights of the two players whose position is 28 and 29. That is, we have to get the average of these two heights, 70 and 73. For that, we have to add these two heights and divide by 2. Okay, when I add 70 and 73, I'm getting 143. And when I divide it by 2, I am getting 71.5. So this is a median height of female players is 71.5 inches. Okay, already we got the median height of the male players, that is 76 over here, and here we have the median height of the female players. Our aim is to get the positive difference between the median height of the male players and the median height of the female players. Now to get the positive difference, we have to subtract the smaller value 71.5 from the bigger value 76. Okay, let me do it. That is 76 negative 71.5. Okay, here when I do such subtraction, I am getting a positive 4.5. That is a positive 4.5 inches. The positive difference between the median height for male players and the median height for female players is 4.5 inches. In the xy plane, a parabola has vertex negative 5, negative 12 and has no x-intercepts. If the equation of the parabola is written in the form y equals to ax square plus 2bx plus 2c, where a, b and c are constants, which of the following could be the value of a plus 2b plus 2c? Okay, here we have the equation of the parabola, that is y equals to ax square plus 2bx plus 2c. Usually we consider this form as a standard form of a quadratic function. And when we have a quadratic function in this form, its graph will be a vertical parabola, which may open up or open down. It depends on the value of the leading coefficient, that is the value of a. A is called the leading coefficient, which is a coefficient of x square. If a is greater than 0, that is positive, then the parabola we get for this quadratic function will open up. In case a is negative, that is less than 0, then the parabola opens down. Okay, now what we can do is using this information, that is the vertex of the parabola, and the question says the parabola has no x-intercepts. We can find whether the parabola opens up or down. Okay, first let me draw an xy plane over here. Okay, so this is the y-axis and here we have x-axis. Okay, now let me mark it. This is x-axis and here we have y-axis. And let me take the x coordinate negative 5 over here and the y coordinate negative 12 over here. Okay, now let me plot the vertex negative 5, negative 12. It has to be over here. Okay, if the parabola opens up, then it has two x-intercepts. One is over here and another one is over here. But the question says the parabola has no x-intercepts. Then the vertical parabola we get for this quadratic function must open down so that it has no x-intercepts. And also the vertex of this parabola is negative 5, negative 12. Okay, from the given information, it's very clear the parabola opens down. Since the parabola opens down, the leading coefficient, I mean the coefficient of x square over here, that is a is negative. Okay, now let's consider the vertex of the parabola. So using this vertex, we can write the equation of the parabola in vertex form, that is y equals to a times x negative h whole square positive k. So this is the equation for parabola in vertex form, and here h comma k represents the vertex of the parabola. For h comma k we have negative 5 negative 12. Okay, let me plug in negative 5 for h and negative 12 for k over here in this equation. Then I'm getting y equals to a times x. Okay, already we have negative and the value of h is negative 5. Negative times negative will become positive. That is a positive 5 the whole square. And for k we have negative 12. Let me plug in negative 12 for k over here. Here I got the equation of the given parabola in vertex form. Okay, now let me get this equation in standard form. That is in this form, y equals to ax square plus 2bx plus 2c. Okay, so y equals to a, and now we have to get the expansion of the square of the binomial over here. For that, let me consider the algebraic identity, that is a plus b the whole square. the square of a binomial, it is equal to a square positive 2ab positive b square. The trinomial we have over here is equal to the square of a binomial a positive whole square. Now to get the expansion of the square of a binomial over here, we can consider this stuff. Okay, here for a we have x and for b we have 5. Now to get the expansion, we have to plug in x for a and 5 for b over here in this trinomial. Then I'm getting, let me write the stuff over here, x square positive 2ab, that is 2 times x times 5, positive b square, that is 5 square, negative 12, y equals to a times x square. Okay, here 2 times x times 5 is 10x and 5 square is 25. Negative 12, y equals to, now we can distribute this a to all the terms inside the parenthesis over here. Then I'm getting ax square, positive 10ax, positive 25a, negative 12. Okay, here I got the equation of the parabola in this form, that is y equals to ax square, positive bx, positive c. Okay, here at the place of a, we have the same a, that is a equals to a. At the place of b, that is a coefficient of x, here we have 10a, b equals to 10a. And for c, that is the constant term, over here is 25a, negative 12. Okay, now let me erase the stuff over here so that I will have enough space to do the problem. Okay, our aim is to get the value of the expression a positive b positive c. Okay, a positive b positive c equals to, for a we have the same a, and for b we have 10a, and for c we have 25a, negative 12. Okay, here let's combine the like terms. So that is 25a positive 10a is 35a, 35a positive 1a is 36a, negative 12. So we got the value of a positive b positive c in terms of a, that is 36a, negative 12. Okay, in the given answer choices, we have value for this expression a positive b positive c. Okay, now let's verify the given answer choices one by one. Okay, now let me verify whether this negative 19 could be the value of this a positive b positive c. Since this 36a, negative 12 is equal to a positive b positive c, instead of a positive b positive c, we can consider this stuff, that is 36a, negative 12. So let me take 36a, negative 12, sorry, 36a, negative 12. Okay, so if this is the value of a positive b positive c, then this negative 19 should be the value of this expression. Okay, now let me evaluate, let me solve for a in this equation. Let me add 12 to both sides of this equation. When I add 12 to both sides of this equation, this negative 12 positive 12 will cancel. I'm getting 36a equals to, when I combine negative 19 positive 12, I'm getting negative 7. Okay, let me divide both sides by 36. When I do so, this 36 will cancel. I'm getting a equals to negative 7 over 36. Okay, here when I consider this value negative 19 for a positive b positive c, I am getting a equals to negative 7 over 36. Since it's a negative value, it has to be less than 0. Okay, already we have guessed the value of a, not the exact value of a, whether a is positive or negative. We know that a is negative, that is a is less than 0. Okay, so the for value negative 19 in answer choice a satisfies the condition we got, that is a is less than 0. Okay, so this could be the value of a. Anyway, so we can verify the other answer choices as well. Okay, now this one, answer choice A satisfies the condition what we got. Okay, now let me check answer choice B, that is we have to verify this value negative 12. Okay, now let me take this negative 12 as a value for this stuff, that is 36a, negative 12 equals to negative 12. Okay, now let me add 12 to both sides of this equation, then this one will cancel. Here also it will cancel. I'm getting 36a equals to 0. When I divide both sides of this equation by 36, I'm getting a equals to 0, which is not possible because in this quadratic function, if a is 0, then there will be no x square term. If there is no x square term, then no parabola will be there. So the value of a can never be 0. Either it can be positive or negative, but we know that a has to be negative. Already we have seen the evidence. The parabola opens down. Okay, so answer choice B cannot be correct. Anyway, so let's verify answer choice B. Let me take this value negative 10 for this 36a negative 12 equals to negative 10. Okay, now let me add 12 to both sides. When I do so, this negative 12 positive 12 will cancel. 36a equals to, when I simplify this one, I'm getting positive 2. Even when I divide both sides by 36, I'll be getting a positive value for a. That is, a is greater than 0. But according to the discussion we have done, a must be negative. But when I take negative 10 as a value for a positive b positive c, I'm getting a positive value for a. So that's not possible. So we can reject answer choice C. Now let me consider answer choice D, that is negative 5. Okay, now let me add 12 to both sides. So here negative 12, positive 12 will cancel. 36A equals to 7. Again, the same thing. When I divide both sides by 36, I am getting a positive value for A. That's not possible. A must be negative. So if I want A must be negative, the value of A positive, B positive, C could be negative 19 in answer choice A. So the remaining answer choices are incorrect. Therefore, the correct answer choice for this question is A. The scatter plot shows the relationship between two variables x and y for data set P. A line of best fit is shown. Data set Q is created by multiplying the y coordinate of each data point from data set P by 4.3. The equation for the line of best fit for data set Q can be written in the form Q of x equals to A positive bx. What is the value of A negative b? Okay, in the given graph, I have scatter plot and line of best fit for data set P. And if I want to get a data set Q, what I have to do is at each point of the data set P, I have to multiply the y coordinate by 4.3. Okay, from the given line of best fit for data set P, let me choose 2 points. Okay, now we have to choose 2 points so that both the x coordinate and y coordinates are integers, so that the calculation process will be easier. Okay, now let me take the point over here. Here the x coordinate is 3 and y coordinate is 2. And let me get a point over here. Here the x coordinate is 1 and y coordinate is 7. Okay, here I have taken 2 points from the line of best fit for data set P, and in both the points the x coordinates and y coordinates are integers. Okay, now let me write the stuff over here. Okay, from the line of best fit for data set P, we have 2 points, 1 comma 7 and other one is 3 comma 2. Okay, from these 2 points, if I want to get the corresponding points for data set Q, what I have is I have to multiply the y coordinate over here and y coordinate over here by 4.3 according to the instruction we have over here. Okay, 1 comma, let me multiply this 7 by 4.3, then I'm getting 30.1. And here 3 comma, let me multiply this y coordinate by 4.3, then I'm getting 8.6. Okay, here I got 2 points for the data set Q. Okay, our aim is to get the equation for the line of best fit for data set Q. Once I get the equation for the line of best fit for data set Q, it can be compared with the equation we have over here. When I do so, I'll be able to get the values of the constants A and B. So from the values of A and B, I'll be able to get the value of this expression A negative B. Okay, since we are trying to find the line of best fit, it will be a linear equation, and we can get the equation of line of best fit for data set Q in slope intercept form. For that, first we have to get the slope of line. Let me consider this is point x1 y1 and this is point x2 comma y2. And when we have 2 points on the line, there is a formula to get the slope of a line, that is m equals to y2 negative y1 divided by x2 negative x1. Okay, here the value of y2 is 8.6 and the value of y1 is 30.1 divided by, and the value of x2 is 3, the value of x1 is 1. Okay, now let me do the subtraction, that is 8.6 negative 30.1. Then I am getting negative 21.5 in numerator. In denominator, 3 negative 1 is 2. Okay, now let me divide negative 21.5 by 2. When I do so, I am getting negative 10.75. Okay, here I got the slope of the line of best fit for the data set Q. Okay, now let me write the equation of line of best fit for data set Q in slope intercept form. That is y equals to mx positive b. Okay, here m represents the slope. Already we got the value of m, that is negative 10.75. Let me plug in this value for m over here. Then I'm getting y equals to negative 10.75 x positive b. Okay, here we have to find the value of b, which represents the y coordinate at the y-intercept. Okay, for that we have to use one of these 2 points. That is, we have to plug in one of these 2 points into this equation to get the value of b. Okay, now let me use a second point. That is, I have to plug in this x coordinate 3 for x over here and y coordinate 8.6 for y over here. Okay, let me do it. Then 8.6 equals to negative 10.75 times 3 positive b. 8.6 equals to, okay, let me multiply negative 10.75 by 3. When I do so, I am getting negative 32.25 positive b. Okay, now let me add 32.25 to both sides of the equation. Let me do it, 32.25. When I do so, this negative value, positive value will cancel out. Okay, now let me add 32.25 and 8.6. When I do so, I'm getting 40.85 on the left side. Okay, let me write over here equals to B. Okay, here I got the value of B. Okay, now what we can do is we can plug in this value for B over here in this equation. Okay, now let me take the equation over here. Then we get y equals to negative 10.75x, positive 40.85. Okay, here I got the equation of line of best fit for data set Q over here. Already we have such an equation over here, that is Q of x equal to A positive bx. Okay, now let me write this equation exactly in this form, and also let me replace this y by Q of x, and here in this equation we have constant at first and then x term. Okay, now let me write this constant 40.85 at first, then write the x term, that is negative 10.75 x. Now the equation we got over here is exactly in this form. When I compare this one and this one, at the place of A, there is a constant term. Over here is 40.85, and here the coefficient of x is B. Here the coefficient of x is a negative 10.75. So when we compare this one and this one, we get A equals to 40.85 and B equals to negative 10.75. Our aim is to get the value of A negative B. That is A negative B equals to, for A we can plug in 40.85. Negative, for B we have to plug in negative 10.75. Okay, 40.85 negative times negative is positive 10.75. Okay, now let me add these two values. So that is 40.85 positive 10.75. When I add them, I am getting 51.6. Okay, here I got the value of the expression A negative B, that is 51.6. 3x negative a the whole square equals to 2x positive j times jx negative k. The given equation has infinitely many solutions where a, j and k are constants. What is the value of a? Okay, the question says this equation has infinitely many solutions. Okay, now what we can do is we can expand the square of the binomial on the left side, and we can multiply the two binomials on the right side. So once you are done with this one, then we can discuss this particular information. There is an equation has infinite many solution. What can we do with this information? Okay, now let me get the expansion of the square of a binomial. Okay, for that what I can do is I can use the algebraic identity, that is a negative b the whole square. Its expansion is a trinomial, that is a square negative 2ab positive b square. When I compare this one and this one, at the place of A we have 3x, and at the place of B we have A. Now to get the expansion for this one, we have to use the trinomial we have over here, and we have to plug in this 3x for A and this A for B in this trinomial. Okay, now let me do it over here. That is 3x whole square negative 2ab. For A we have 3x, and for B we have A positive b square. For B we have A, that is A square. And here we can multiply these two binomials using the FOIL method. Let's multiply the first term. So 2x times jx can be written as 2jx square. Now let me multiply the outer terms. 2x and negative k, it can be written as a negative 2kx. Now let me multiply the inner terms. Positive j times positive jx, then I'm getting positive j square x. Okay, now let's multiply the last terms. Positive j times negative k, that is negative jk. When I simplify this one, 3x whole square, I am getting 9x square negative. When I multiply this 2 and 3x, I am getting 6x. 6x times a is 6xa, or it can be written as 6ax positive a square equals to 2jx square. And here we find the variable x in both the terms over here. So what we can do is we can factor the variable x out. When I factor the variable x out, I am left with negative 2k in the first term and positive j square in the second term. X is factored out negative jk. Okay, after simplification, this is the equation I am getting from the given equation, and the question says the given equation has infinitely many solutions. That is, this equation is true for all real values of x. Since it is true for all real values of x, the coefficients of like terms on both sides must be equal. When I consider the coefficient of x square on the left side, that is 9. The coefficient of x square on the right side is 2j. They must be equal. And now let me compare the coefficients of x. Here the coefficient of x is negative 6a, and here the coefficient of x is negative 2k positive j square. And the constant term on the left side is a square. The constant term on the right side is negative jk. Okay, now let's solve for j in this equation. For that, we have to divide both sides by 2. When I do so, this 2 will cancel out. 9 divided by 2 is 4.5. On the right side, we have j. Okay, here I got the value of j. Now we can plug in this value 4.5 for j over here and here. Okay, let me do it. Negative 6a equals to negative 2k, positive 4.5 the whole square, and here a square equals to a negative. For j we can plug in 4.5, that is we get negative 4.5k. Okay, now let's solve for k in terms of a in this equation. Negative 6a equals to negative 2k. When I evaluate the value of this 4.5 the whole square, its value is 20.25. Let me subtract 20.25 from both sides of this equation. Okay, let me do it. When I do so, this positive value, negative value will cancel out. I am getting negative 6a, negative 20.25 on the left side. On the right side, we have negative 2k. When I consider the terms of this equation, each term has a negative sign. Now to get the negative sign that we have for each term, we can multiply each term of this equation by negative 1. Okay, now let me continue over here. When I multiply this negative 6a by negative 1, I am getting positive 6a. And when I multiply this negative 20.25 by negative 1, I am getting positive 20.25. And here when I multiply this one by negative 1, I am getting positive 2k. Now to solve for k, let me divide each term by 2. Let me do it. Here this 2 will cancel out. When I divide 6a by 2, I am getting 3a. And here when I divide 20.25 by 2, I am getting 10.125. On the right side, we have k. Okay, here I have solved for k in terms of a. Now let me plug in this stuff for k in this equation. Then we get a square equals to negative 4.5 times for k, we can plug in this stuff. Then I'm getting 3a positive 10.125. Actually, it is a quadratic equation in terms of the unknown a. Now we can use Desmos graphing software to solve for a in this equation. Okay, now let me go to Desmos graphing software. Here we have a Desmos graphing calculator, and I want to solve this equation for a using Desmos. Okay, when I want to solve this kind of implicit equations using Desmos, the implicit equation must contain either x or y. But in our equation, we have the unknown a. Now to solve this equation using Desmos, what I have to do is I have to use either x or y at the place of a. If I use x at the place of a, then I have to consider the x-intercept of the graph to get solution for this equation. In case I use y at the place of a, then I have to consider the y-intercept of the graph to get solution for this equation. Okay, now what I am going to do is I am going to consider x at the place of a. Then the given equation will become x square equals to negative 4.5 times 3x positive 10.125. Okay, here I got the graph of the equation over here. And the equation over here is a quadratic equation. When we solve a quadratic equation, we'll be getting two solutions usually. Sometimes we'll be getting only one solution. Sometimes we'll be getting no solution. Okay, when I look at the graph over here, the graph intersects x-axis at only one point. So I think there is only one solution for this equation. And to get that solution, let's consider the x-intercept we have over here. So the x-intercept over here is negative 6.75, 0. Now to get the value of x in this equation, we have to consider the x coordinate over here, that is negative 6.75. Actually, we use x at the place of a. So the value we got over here as x coordinate is the value of a. Therefore, the value of a is negative 6.75. f of x equals to negative a to the x to the power positive b. The function f is defined by the equation above where a and b are constants. The graph of g of x is formed by taking the graph of f of x and translating it both 6 units in the negative x direction and 2 units in the negative y direction. The x coordinate of the x-intercept for the graph of g of x is negative 3 and g of negative 6 equals to 61 over 64. What is the value of a? Okay, here we have the function f of x, and the question says we have to apply two transformations on the function f of x to get the graph of the function g of x. So the two transformations are 6 units in the negative x direction, 2 units in the negative y direction. Negative x direction means it is an horizontal translation to the left, and negative y direction means it's a vertical translation down. Okay, since we do horizontal translation of 6 units to the left, the x in the function f of x has to be replaced by x positive 6. And since we do a vertical translation of 2 units down, that is a negative y direction, y in the function f of x has to be replaced by y positive 2. Okay, when we do horizontal translation to the left, we use positive sign. In case we do horizontal translation to the right, instead of positive, we'll have to take negative sign. And the same thing, when we do vertical translation down, we use positive sign over here. When we do vertical translation up, instead of positive, we have to use negative. Okay, now let me take the given function f of x as y equals to f of x. According to the instruction, we have to apply the two transformations over here. That is translating 6 units in the negative x direction, 2 units in the negative y direction. Then we have to replace this y by this y positive 2. We get y positive 2 over here. F of, we have to replace this x by x positive 6. Let me do it. Okay, since I have applied the given two transformations on the function f of x, now it has become the function g of x. Since it has become the function g of x, we can replace this y by g of x. Then we get g of x positive 2. Now to get the stuff for f of x positive 6, we have to plug in this x positive 6 for x over here. The same we have to do on the right side. That is, we have to plug in this x positive 6 for x over here. Then I'm getting negative a to the power of x positive 6 positive b. Now let me solve for g of x. For that we have to get of this positive 2. Okay, now let me subtract 2 from both sides of this equation. Then positive to negative will cancel out. I am getting the function g of x on the left side. On the right side we have negative a to the power of x positive 6 positive b negative 2. Okay, here we got the function g of x. Now let me consider this particular piece of information. That is the x-coordinate of the x-intercept of the graph of g of x is negative 3. So this negative 3 is the x-coordinate of the x-intercept. Okay, in an x-intercept, always the y-coordinate is 0 and the question says the x-intercept is negative 3 for the graph of the function g of x. Okay, here in this one, this g of x represents a y. So we can plug in this y coordinate 0 for here, and this x coordinate negative 3 for x over here. Then I'm getting 0 equals to negative a to the power of negative 3 positive 6 positive b negative 2. Okay, 0 equals to negative a. When I simplify this one, I'm getting exponent 3 positive b negative 2. Okay, here there are two unknowns. One is a and the other one is b. According to the question, we have to find the value of the unknown a. Okay, now to get the value of this unknown a, we must find the value of this unknown b. Okay, how do I have to find the value of b? For that, we can consider this information. That is g of negative 6 equals to 61 over 64. Here we have negative 6 at the place of x. Now what we can do is we can plug in this negative 6 for x over here and here. Then I'm getting g of negative 6 equals to negative a to the power of negative 6 positive 6 positive b negative 2. And we have value for this g of negative 6, that is 61 over 64. Let me plug in. Okay, here negative a to the power of negative 6 positive 6 will become 0 positive b negative 2. Okay, 61 over 64. The value of this a to the 0th power is just 1, that is negative 1 positive b negative 2. Okay, let me continue over here. That is 61 over 64 equals to b. When I combine negative 1 and negative 2, I am getting a negative 3. Okay, now let me add 3 to both sides of this equation. Negative 3 positive 3 will cancel out. I am getting 61 over 64 positive 3 equals to b. Here we add a fraction and an integer. When I add a fraction and an integer, I have to multiply this integer by this denominator. Then we can take this 64 as a common denominator. Let me do it. 61 positive, 64 times 3 is 192. And now we can take this 64 as a common denominator equals to b. Okay, let me continue over here. When I add 61 and 192, I am getting 253. In denominator we have 64. Here on the right side we have b. Okay, here I got the value of b, that is 253 over 64. Okay, now what we can do is we can plug in this value of b, 253 over 64 here in this equation and solve for a. Okay, now let me do it. That is 0 equals to negative a cube positive, and for this b we can plug in this value 253 over 64 negative 2. Okay, now let me add a cube to both sides of the equation. When I do so, this negative a cube, positive a cube will cancel out. On the left side, when I come in 0 on positive a cube, I am getting a cube. On the right side, we can simplify this one. That is, we do subtraction between a fraction and an integer. Now we have to multiply this integer by this denominator. Then we can take this 64 as a common denominator. Okay, let me do it. 253 negative 64 times 2 is 128. Now we can take 64 as a common denominator. Okay, here a cube equals to, when I simplify 253 negative 128, I am getting a 125 over 64. Then we get a cube equals to, now we can write this 125 as 5 to the third power and this 64 as 4 to the third power. Okay, let me continue over here. A cube equals to, here we have two powers in a fraction with the same exponent. Now we can write this exponent 3 in common, that is 5 over 4 raised to the power of 3. Okay, now two powers are equal with the same exponent. Whenever two powers are equal with the same exponent, what we can do is we can equate the bases. Then we get a equals to 5 over 4. Okay, here I got the value of a, it's 5 over 4.